This lesson is about finding the area of rectangles with whole by mixed and whole by fractional number side lengths and relate to fraction multiplication. A lot of what we're trying to do today is coming back to the area model, so a lot of this will look similar to that as we go forward and as to what we've done before with the area model. One of the big ideas and vocabulary words repeated by the curriculum throughout this lesson is the word tiling. So think about how you might tile a floor where you're redoing your bathroom or redoing the kitchen floor. We're going to use a similar concept as we're going through this lesson. So to define tiling, it's a strategy to find a rectangle's area by covering the entire figure with square units and fractional parts of a square unit. Okay, go back to what I was just saying about a floor where you're laying tile, you're putting tiles down. Okay, it's the same idea, looking at how many tile pieces do I need and how many fractional pieces do I need. We could have something like this, where we have a black rectangle and we're looking at the smaller pieces inside of it. Okay, going from top to bottom, the length is 6 units, and you can count up the 6 different units going vertically. And then horizontally, we have 4.5 units, where we have 1, 2, 3, 4 whole units, as represented in red up at the top, and a half unit going down along the side. So imagine that's your floor. Okay, what they want you to do is see how many full tiles you'll need in the middle and how many half tiles you'll need in the side in order to cover the entire floor. And the way that I would do that personally is I would start with my whole tiles here, and I would do an equation of 6 times 4, because I have that array that we've looked at before where we have, really it's the length times the width to find the area of the whole number, but then we're also going to add in the half units, and we have 6 half units, so we're going to do 6 times 1/2 in order to cover this smaller section here. And I know that 6 times 4 is 24, and then I'm going to add 6 times 1/2. 1/2 of 6 is 3, and then if I add them together, I have 27 units, and those are squared units, because remember we have our square tiles. And if we wanted to, we could count them up, go 1, 2, 3, 4, 8, 12, 16, 20, 24, and 1/2, 1, and a half, 2, and a half, 3, and then 3 plus 24 is 27. So that's another way to get to the same solution. Don't let the vocabulary of tiling confuse you or throw you off as you're working through this. Okay, really, this is another way of looking at the area for the problem, where you have 6 units times 4.5 units, which still gets you 27 units. Which, again, when you use your area formula, you can do 6 times 4.5, which still gives you 27 square units. Use that information to solve this problem. This rectangle is composed or created of squares that are 3 1/4 inches on each side. What is its area of the entire rectangle in square inches? Okay, remember it's saying it's composed of squares, so each side of the square is 3 1/4 inches. Go ahead and solve it. Before we go too far, what I would do is I would find the length and the width. And remember to write down my area formula. Okay, so for my length, I have 3 squares, and each square has a side that is 3 1/4, so I do 3 times 3 1/4. For my width, there are 4 squares, so I would do the same, 4 times 3 1/4. And then I'm going to move this to the side, and I'm going to write down my area formula, which is area equals length times width, and which you should remember from 4th grade. And then I can plug in my values as I start to solve this. So I'm starting with my area formula that I'm filling in. Area is the same as length, which is 3 times 3 1/4, which I don't have a value for yet, times 4 times 3 1/4. And I need to find those values, and then I can finish solving for my area. Okay, when I go through and solve this, I see that the area of this is 126 3/4 inches squared. And remember, we're looking at the area, so it is inches squared. Do not get that confused with the volume for cubed. Try this last problem. A rectangle has a perimeter of 27.5 feet. If the width is 13 feet, what is the area of the rectangle? And I want you to draw this one out. First draw your rectangle, then determine the length of each side, because remember, you're starting with perimeter, not with area. And then what I'd like you to do is calculate out the area and double check your work. After you saw the problem, you should see in your rectangle that you have 13 feet as your length, and you have 3/4 as your width, or flip it around, 13 is your width. Okay, many of you are going to confuse and say 13 feet is one, and then you'll have 14.5 for the other, but don't get that mixed up. And then once you do have your width and your length, you're able to plug them into the area formula, length times width, and then solve it and see that you have 9 3/4 square feet as your final area.